Okay, so we are doing polynomials in this unit. So today what we're going to do is we're going to divide polynomials. There is a purpose to why this lesson is in this unit, and you will see the connection here in a second. So first of all, you're going to be able to divide polynomials by long and synthetic division. So those words should not seem completely foreign to you. It's just been a while. So far in this chapter, we have been studying polynomials by their graphs. Now we're going to take a more algebraic approach to polynomials by using division. And it's very just procedural. You follow exactly the steps I give you. So dividing polynomials is much like the process of dividing numbers. Now, a lot of us get out of the habit of knowing how to actually do this because we have calculators and whatnot. So just let's look here. When we take 38 and divide it by 7, it doesn't divide evenly. Do you agree? So it doesn't divide perfectly. So with that being the case, we would get 5, because 7 times 5 is 35. Do you guys see? So it goes into it perfectly 5 times. But then there's some remaining amount. So look, 7 times 5 equals 35. How many remaining to get to 38? 3. So then we have a 3 as our remainder. Does everybody see? So this is just how we write it. We got 5 plus 3 when we divided by 7. We add the remainder here. And then it's when we divided by 7. And then if we were to go backwards and get a common denominator and combine like terms in our numerator, we'd end up right back here. So this is what's called the quotient. 5 is the quotient, so that's what your answer is. It's called the quotient, and the remainder is 3. Now, isn't it true, since it did not divide perfectly, since our remainder wasn't 0, isn't it true that 7 and 5 are not considered factors of 38? Factors means multiply to be 38, yeah? But we can still divide them, it's just we don't get a very pretty answer. Okay. So that idea is exactly the same as polynomials. Okay, write this down. This is called the division algorithm. It's actually really easy. It's exactly what you just saw, but it's just writing it out as polynomials instead of numbers. So it says, if p of x and d of x are polynomials where d of x does not equal 0. Now I'm going to pause there. Look, see how we're dividing by d of x? It obviously can't be 0, right? We can't divide by 0. That's why they're saying that. We have to be able to understand some definitions here. It says, then there exists a unique polynomial q of x. There exists a unique polynomial q of x and r of x where r of x is either 0 or of a degree less than the degree of d of x. So basically write these down and then I'm going to explain them. So p of x equals d of x times q of x plus the remainder. R of x would be our remainder. And another way of saying this exact same thing is this. If we take p of x divided by d of x, we're going to get a q of x plus our remainder. Saying the same thing, just written a little differently. So a second ago we saw this. We saw 38 divided by 7, and we got equals 5 plus 3 over 7. That's what we just saw. This is exactly that. See, look. Right, this is this. Look, it takes p of x divided by d of x, so our p of x would have been 38, d of x 7. It equals some amount. It equals 5. And then plus the remainder. Do you guys see how it is the exact same thing? Now, if this is true, isn't it also true that 38 will be equal to 7 times 5 plus the remainder? Didn't we say that's how we got back to 38? So it's literally just saying, well, if this is true, then also this is true. That 7 times 5 plus the remainder would equal 38. So it's just different ways of writing out the division process. What was that? In this statement right here, but this one's writing it a different way. This is saying, isn't 38 equal to, since we did 38 divided by 7, and it came out to be 5, with a remainder of 3/7, isn't it also true that 7 times 5 plus the remainder equals 38? It's just writing it out all differently, because it's going to ask us to do that, so I just wanted you to see that they're the same thing. But it's going to make more sense once we see some examples of actual polynomials. Okay, so everybody write this problem down. I'm going to give you a second. These are the steps we take to long division. I'm just going to show you the steps. I'm not going to write them out. It's too hard to write them out. It's just a process that you have to follow. Basically a memorization process, if we're being honest. So long division, understand, always works. We can always take two polynomials and use this process. Long division always works. So the first thing we do is we set up what's being divided. So this is being divided by x minus 4. Our divides, what's being divided goes inside our quote house. So I go, okay, we have a little house here like this, and underneath is 6x squared minus 26x plus 12. And on the outside of our house is what we're dividing by, which is x minus 4. That is step number 1, to set it up correctly. Then I do what I call like bulletin points, just showing my work. I highly recommend you showing your work as such. So with long division, you guys, all you ever divide is the leading terms. So we're going to go off to the side and make a little bulletin point, because then it's easy for me to help you if you've made errors and to check your work. The leading term is this. The leading term is this. Does everybody see? We only divide the leading terms. Now we're obviously taking this and dividing it by this. That's what was happening. See, this divided by this. So you're going to go off to the side and say 6x squared divided by x. And you're actually going to go ahead and divide them. So what is 6x squared divided by x? 6x. That is part of your answer. So that goes on top. Right here. Sorry, I'm drawing down here. So that goes on top. I like to line things up. So here's my x squared, here's my x's, here's my constant. So I'm going to write it right here. It's not like life or death if you don't, but it's kind of nice. Okay, so that is part of our answer. And now what we're going to do is we're going to take that top thing, that 6x, and we're going to distribute it down back into x and negative 4. So now go 6x times x. What do we get? 6x squared. Now notice, aren't these the same? That's always going to happen. Now 6x times negative 4 is negative 24x. Now this is the really important thing you have to remember. The next thing that we need to happen is we need these to cancel out, to add up to be 0. Right now they add up to be 12x squared, don't they? So we need to change the sign. So what we're going to do is we're going to do it to both pieces, but we're going to change the sign. Basically we're like factoring out a negative 1. We're going to times by a negative 1. So we're going to change this to a negative, so we've got to also change this sign. So that would change that to a positive. Right, never do anything with the top one. So now what we're going to do is add straight down, combining like terms. Literally just combine like terms. So 6x squared minus 6x squared, gone. That should always cancel out. Now negative 26x plus 24x is negative 2x. Now notice I'm just crossing out and what's under the house, and then we have a plus 12 and there's nothing to add it to, so we just have plus 12. And now we just have a new problem. We're literally starting this roundabout process over again. So we literally just say, okay, starting over. We go make a bulletin point. Your leading term is to negative 2x, your leading term is x. So start the process over. You'll take negative 2x divided by x, and we get out negative 2. That's part of your answer. So we put it on top, minus 2. Now I'm going to take the negative 2 and distribute it through. Negative 2 times x is negative 2x. Don't change your signs yet. Just wait. Negative 2 times negative 4 plus 8. Now remember, your leading terms we're wanting to cancel out. Right now they won't, so you'll take the bottom thing here, change the sign, add straight down. That is gone, and now 12. Oh, I just was like worried because I heard something going on and I'm like, oh. I thought you were like hurting someone. We get out 4. Okay, now here's how we know we're done. If we go off to the side, it will not divide. We can't take 4 and divide by x, can we? So that's your remainder. So our remainder is 4, everybody. Now let me explain something. Remainder 4. You can't write your answer like that. That's not an appropriate way. So this is how we write our answer. Instead of writing remainder 4, we say, okay, we add our remainder, just like we did in the 38 divided by by 7. We got out 5, and we added 3 divided by 7. So we're going to add 4. We're going to add 4, and what did we divide by? X minus 4. So your final answer is 6x minus 2 plus 4 over x minus 4. So now, isn't it true that we know for a fact, okay, that's your answer, but I just want to make a point here. Isn't it true that since our remainder was not 0, that x minus 4 must not be a factor of that quadratic? True? And this also must not be a factor. But isn't it true, we could still write it as the product of two factors, we just have a remainder. So isn't it true that this 6x squared minus 26x plus 12 is equal to this times this plus that? So we could say, well, if they said rewrite this as this format, you'd say, okay, well, 6x squared minus 26x plus 12 is equal to x minus 4 times by 6x minus 2 plus 4 over x minus 4. Does that make sense, everybody? They are equivalent. If you were to distribute this out and then get a common denominator and combine like terms, you would end up at 6x squared minus 26x plus 12. No, I'm just showing you because they might ask you, like in the next example. They'll ask you sometimes, but they'll say write it, and they'll show you the format they want you to write it in. So our answer right here just said divide. This would be our answer. Okay, let's do another one. Okay, so it says, let p of x be this, and d of x be this. Find polynomial, this is the example of that. Find polynomial q of x and r of x such that p of x equals d of x times q of x plus the remainder. So basically we need to do long division and then rewrite it in this format. So we would set up what's being divided. So it says p of x and d of x, and we're obviously going to be taking p of x divided by d of x. So we would put on the outside 2x squared minus x plus 2. Inside our house would be 8x to the 4th plus 6x squared minus 3x plus 1. Okay, so we have this all set up. We're going to go do our bulletin point. Remember, we divide the leading terms. Isn't that 8x to the 4th and 2x squared? So we'll go 8x to the 4th divided by 2x squared, which is 4x squared. So that's part of our answer. I like to line it up, so notice my x squareds are right here. 4x squared. Now don't we distribute it down to each thing in this little thing that was that we were dividing by. 4x squared times that is 8x to the 4th. 4x squared times negative x is negative 4x cubed. 4x squared times positive 2 is positive 8x squared. Now we need to change the sign, don't we, on that thing that we just put. So negative, positive, negative. And now we're going to combine like terms, adding straight down. 8x to the 4th minus 8x to the 4th is gone. Now, people always freak out in this situation. They're like, well, look, an x squared and an x cubed. Yeah, you're right. You can't combine those. So, combine the x cubes. We have 4x cubed. Any other x cubes in here? So, we have a 4x cubed. Then 6x squared minus 8x squared is negative 2x squared. Then we have a minus 3x. Then plus 1. And now we're just starting over again. No, there's going to be some times where they all add up together. But yeah, but yes, only the leading term will end up usually canceling out. Anything that doesn't cancel out in order from like highest degree to lowest degree will be your new leading term. Yes. Okay. So now starting over, bulletin point. Leading term is 4x cubed, 4x cubed divided by leading term 2x squared, which is 2x. True? So that goes on top. That was positive 2x, so plus 2x. And now we'll distribute. We get 4x cubed. Distribute again, minus 2x squared. Distribute again, plus 4x. Now we change our sign. Change our sign. Change our sign. And now we'll add straight down, combining like terms here. 4x cubed minus 4x cubed is gone. Negative 2x squared and positive 2x squared also cancel out, which is fine. Keep going. So then, negative 4x minus 3x. Negative 7x plus 1. Now look, look at the leading term, negative 7x, does it divide evenly, or does it, not that it doesn't divide evenly, but can we take and divide it by 2x squared? No, so that's your remainder, all of that. So our answer is, don't we add our remainder? So you'd say plus negative 7x plus 1 over what we were dividing by. This, over 2x squared minus x plus 2. So that's your quotient, right here's your quotient, right here's your remainder, and it wants us to write it in this format. Take p of x and equal it to some d of x times some q of x plus the remainder. So this is how we would write our final answer. I need a lot more room here. Okay. So all we need is all this stuff right here. We need that, that, that. Okay, that's probably good enough room right there. Okay, so our final answer would be our p of x, which was 8x to the 4th plus 6x squared minus 3x plus 1 equal this times this plus this, correct? Okay, so you'd say equals, parentheses, 2x squared minus x plus 2 times 4x squared plus 2x, and then plus negative 7x plus 1 when we divide it by 2x squared minus x plus 2. It's just long. Yep. All right, that's probably enough practice with long division. Do you agree? Okay, cool. Let's move on to the next type here. Okay, if you don't need more practice, I'm just going to move on. I wanted to give you the option to do one off the homework by yourselves before we move on, but if you feel confident, let's just keep going. Okay, synthetic division is another way of dividing polynomials. Why do we learn two ways? Because here's why. Synthetic division is way easier, way quicker than long division. But the problem is you can only use synthetic division in very limited cases. Now, if we can use synthetic division, we'll always choose that over long division. But here's when you can use synthetic division. So, you can only use if you're dividing by something that is linear, not the thing that's being divided. If you're dividing by something that is linear, that means degree 1 with a leading coefficient of 1. 1 and 1. That has to be true. And if that's true, then you can use synthetic division. So basically, guys, don't we just have to be dividing by a linear factor with leading coefficient of 1? Because 2x plus 3 is still a linear factor, but it doesn't have a leading coefficient of 1. All right. So this is how you'll set up synthetic division. Now, synthetic division, we actually use the 0, not the actual factor. So instead of using x minus 3, we set x minus 3 equal to 0, and we solve for x. X equals positive 3. Does everybody see? Synthetic division, we use the 0. So we put our 0 on the outside of our house, and our house is like an upside-down house with more room. So notice I draw in, just give yourself plenty of room like I just did. With synthetic division, we now, inside our house, put in the coefficients only. Coefficient means number in front of the variable, and we have to be absolutely sure missing anything. So if you're missing a degree, if you're missing like an x here, you would need to put in a 0. It has to fill in from highest to lowest degree, all the coefficients. So it's 2, 1, constant, so we're not missing anything. 2, -1, and -3 are my coefficients. And then these are the steps you take to synthetic division. Literally, this is what you do. Add straight down, multiply up. Add straight down, multiply up. So we're going to start here at this first term. Add straight down. Now notice this first term will be 2 plus nothing, because there's nothing here. What's 2 plus nothing? 2. Boom. There's your first little piece of your answer. Add straight down, multiply up. Add straight down, multiply up. So now we're going to take 2 and multiply it up to 3. What do we get? 6. So we're going to place 6 right here in this next spot. And then we just add straight down, multiply up. So add straight down. 5. Now we multiply up. 5 times 3 is 15, and we add straight down. And we're done. Now everybody look. We took something that was degree 2, we divided by degree 1. X squared divided by x to the first equals x, correct? This is our leading coefficient, and it starts with an x. We just divided it down, so now this is 2x. Then we have a plus 5, because that would be what comes next after x, the constant, correct? And our last thing will always be our remainder. So we'd say plus 12 when we divided by x minus 3. So this just gives us the coefficients, and then we fill in the rest. So question for you, is x minus 3 a factor of the quadratic? No, because the remainder wasn't 0. However, we can still divide it, it just doesn't come out pretty. So don't we know for a fact that 3 is not a solution of this quadratic? If that's not a linear factor, then that's not a solution. Does everybody see how we can kind of use this maybe in the future? Okay, awesome. So that would be your answer. We'll do another synthetic division one. Okay, let's do another one. Use synthetic division to divide this by this. Now this is one you don't want to get to the test. Guarantee that we see you put one on there that's synthetic division that is missing a term. Because so many people forget to put in the coefficient. So notice we're missing an x. So there's really 0x there. We got to put that in. So we use our 0, which is 3, isn't it? And we put in our little thing, our little house, and we put in our coefficients. So the highest degree was 3, so our 2, then our -7, then 0, then 5. There's our coefficients. And then we add straight down, multiply up. So I add straight down, 2 plus nothing is 2, multiply up, 6. Add straight down, -1, multiply up, -3. Add straight down, multiply up, add straight down. Now we took degree 3, we divided by degree 1, so where are we going to be at? Degree 2. So this is 2x squared minus 1x minus 3, and our remainder must be -4. That last thing is always the remainder. So we'd say -4 when we divided by x minus 3. So now we know for, once again, just making sure that I say it every time, we know for a fact x minus 3 is not a linear factor of this quadratic, or sorry, of this cubic, therefore 3 is not a solution. Just for future reference. Okay. You guys good with synthetic? Okay, cool. How awesome are you guys? Okay, I think we're good. Okay. Almost there, everybody. We're winding down. We have a last few theorems to know. So this is what's called the remainder theorem. It's actually really easy. So fun fact for you. If we take, so I'll read the definition, then I'll kind of put it in easier terms. If a polynomial p of x is divided by some linear factor of x minus c, then the remainder is going to be the value of p of c, where c is the 0. So, fun fact for you, is it true that I could take this polynomial and I could divide it by x plus 2? I could use long division, I could use synthetic division. I'm going to get a remainder. Do you agree? Well, I can also find the remainder by C is the 0, so what would my 0 be here? -2, which makes sense. If x minus c is a factor, c will be a 0. What we can do is it says we can take and plug in p of c. So we can take -2 and plug it in, p of -2. We can do some calculations, and guess what we're going to get out? The remainder. So if you plug in the 0, it will also calculate to be the same as the remainder. So it's just two different ways of being able to find the remainder. Either plugging in the 0 or doing long and synthetic division. Same idea as synthetic, basically. So right here it says find the quotient and the remainder. Because it's asking us not to also find the quotient, we do need to go through and divide this. Let's use synthetic division. So we know we use our 0, -2, we put in our little house, we put in our coefficients. 3, 5, I'm missing, -4, aren't I missing an x squared? 0, 7, 3. So now we'll add straight down, multiply up, add straight down, multiply up, add straight down, multiply up. Have I made any errors anywhere? Add straight down, multiply up, add straight down, multiply up. Looks like that's going to be 2. Add straight down, we get 5. So our answer, we went from degree 5 divided by degree 1, therefore it's degree 4. So this is 3x to the 4th minus x cubed minus 2x squared plus 4x minus 1, and the remainder was 5. So plus 5 when we divided by x plus 2. So it says find the quotient and the remainder. We've done that. Now it says use the remainder theorem to find p of -2. What do we already know that when we plug in -2, what answer are we going to get out? 5, right? 5. So we can make sure we've done it right. We'll go ahead and plug it in. So right here, 3, and then -2 to the 5th plus 5 times -2 to the 4th minus 4 times -2 cubed plus 7 times -2 plus 3. And you would type it into your calculator, and guess what? It calculates to be 5. So question for you. Isn't it true that since the remainder is not 0, we know that -2 is not a solution and x plus 2 is not a factor? So which way do you like better? Is it quicker to do synthetic division? If I said to you, is x plus 2 a factor, a linear factor of this? Do you find it quicker to actually just plug in the 0 and know that the remainder wasn't 0, or is it quicker to do synthetic division? I think it's quicker to do synthetic. Yeah. Awesome. It doesn't matter though, right? That's why we won both. Okay, awesome. So let's read just so when we get to the homework we're not lost. So let's read this. It says use synthetic division and the remainder theorem to evaluate p of c. Now notice in this one it says c equals -1. Do you see how in this one they're already giving us the 0? They're not giving us the linear factor. Do you guys see? They've already solved for us. So it wants us to use the remainder theorem. So that means plug it in. P of -1 equals 4 times -1 squared plus 12 times -1 plus 5. So wouldn't that be 4 and then -1 squared is times 1, right? Minus 12 plus 5. So what will our remainder be? Correct. -11, right? Oh, no. 9 minus 12. Sorry. 4 plus 5 is 9, right? 9 minus 12. So -3. Sorry. -3. So our remainder is -3. Therefore, is -1 a solution? No. Now that one was pretty quick just to plug in. So we've used the remainder theorem instead of using synthetic division. Pretty straightforward stuff, as long as you know what you're doing. All right, another theorem, but we already know it. I've been saying it the whole time. It says if c is a 0, when we set the polynomial equal to 0, c is a 0 if we set the polynomial equal to 0, if and only if x minus c is a factor of p of x. So it says, basically guys, if x minus 1 is a factor, is 1 a solution? Like look at part A. If x minus 1 is a factor, is 1 a solution? That is literally what this theorem says. So read it again. C is a 0. when we set the polynomial equal to 0, if and only if x minus c is a factor. Do you guys see I was just saying that? All right, so it is a factor if you divide p of x by x minus c and the remainder is 0. So we already know this. So it says right here, is x minus 1 a factor? If so, factor completely. So we'd say, well, we don't know if it's a factor until we see if we have a remainder of 0. So I'm going to do synthetic division. I'm going to put in my 0, which is 1. X equals 1. Make my little house. 1, x squared is missing, 0, negative 7, 6. So I put in my coefficients. Then I add straight down, multiply up, add straight down, multiply up, add straight down, multiply up, add straight down. Is the remainder 0? So you'd say yes. Now it says, if so, factor it completely. So what do we know? Well, we know that it's true that x cubed minus 7x plus 6 is equal to, this was a factor, so we have an x minus 1, don't we? And then we just got this new polynomial, which was degree 3 divided by degree 1 is degree 2. So this came out to be x squared plus x minus 6. So we also have x squared plus x minus 6. Isn't that a true statement right there? All right, so then from there, we would say, okay, I'm asked to factor it completely. I have a quadratic. Let's see if the quadratic factors one more time. So it multiplies to be negative 6, adds up to be 1, 3 times 2, negative 2. It can quick factor, can't it? So we have an x minus 1, and we have an x plus 3, and an x minus 2. So we've now factored it completely. Now it says, is p of 2 equal to 0? What does that literally say? Isn't this just an xy point, everybody? Look. Isn't p of 2, isn't that saying that x equals 2? And what would we get out if we plug that in? Y value of 0, right? That's what this says. Plug in 2, get out 0. Isn't that an xy point here? Is that going to be true? Look at your linear factors. If I plug in, is 2 a solution? Then when I plug it in, won't it become 0? Yes. Look, 2 minus 2 is 0. 0 times anything is 0. So do you guys see how you can, now that you have it factored completely, you can say that 2 will also make it 0. So yes. Okay, so it's just worded a little bit more advancedly than when you took it in Sec 3. As you can tell, it's just worded a little bit more. All right, winding down here, we only have 2 more slides. Find a polynomial of degree 4 that has these 4 zeros. Now remember, if you have degree 4, you have 4 solutions, period, correct? Now some of them might be real, some might be imaginary. This one's telling us we have a degree 4, an x to the 4th polynomial, with these as the solutions. So isn't it true that x equals negative 3, x equals 0, x equals 1, and x equals 5? So now we need to work backwards. It wants to know what's the polynomial that would generate those answers. So now we need to work backwards. Well, if x equals negative 3 is a solution, isn't x plus 3 a linear factor? And isn't x equals 0, so we would just have an x, true? And we would have an x minus 1 as a linear factor, wouldn't we? And x minus 5. Now everybody listen, it wants it in standard form. So this is always how you multiply out 1, 2, 3, 4 pieces. Multiply 2 together, multiply 2 together, and then multiply those together. So let's just focus here. X times x is x squared, right? X times positive 3 is plus 3x. Boom, done. Now let's do this one. X times x is x squared. I'm going to do it over here because there's going to be some like terms. X squared, x times negative 5, negative 5x. Negative 1 times x is negative 1x. Negative 1 times negative 5 is plus 5. So we also have an x squared minus 6x plus 5. And now we're going to be able to multiply all those together by triple distribution, basically. X squared times x squared is x to the 4th. X squared times negative 6x is negative 6x cubed. Notice I draw my arrows as I go. X squared times positive 5 is positive 5x squared. And then watch what I do. I've distributed x squared through to all this stuff, haven't I? I cross it out so I don't start doing weird stuff like double dipping. Positive 3x times x squared is positive 3x cubed, I'm going to line it up right here. Positive 3x cubed. Positive 3x times negative 6x is negative 18x squared. Positive 3x times positive 5 is positive 15x. And then we're almost done. We add straight down. X to the fourth, no other x to the fourth. Negative 6x cubed plus 3x cubed is negative 3x cubed. 18, 17, 16, 15, 14, 13. So negative 13x squared, and then plus 15x. And there's your answer. That polynomial has those 4 zeros. Notice it's degree 4. So it's just going the other way. So if I said solve, we would factor it, and we'd get those. Okay, cool. Okay, this is the last example. This is the last example of the day. Okay, find a polynomial of degree 3 that fits the graph. Don't we use the zero method? So we have x equals 3 and x equals negative 1, but that's only 2 solutions. If I multiply out that, won't it be degree 2? One of them bounces, so what does that mean? You're right. So we also have another negative 1. It had multiplicity of 2. Because it bounced. Yeah, it didn't cross through, it bounced. So we know it has multiplicity that's even. Do you guys see? And if it's degree 3, then there only can be 3 solutions. So now we'll work backwards. We have an x minus 3. We have x plus 1. We have x plus 1. So when multiplying 3 things out, always multiply 2 together and then multiply in the third. I'm going to just multiply these 2 together. So I'd get x squared plus x, that's plus 2x. 1 times 1 is 1, don't call it 2, so plus 1. And now we'll multiply in x minus 3, x cubed, plus 2x squared, plus x. Crossing that out, negative 3x squared, minus 6x, minus 3. Adding straight down, x cubed, minus 1x squared, minus 5x minus 3. Okay, that is the end of the lesson. So now you should be able to do that homework, and you have your paper with the homework problems.